Alright, our next sample is going to be Lussac Law, which is one of the worst sounding names possible to have, but I'm pretty sure it was two people. I don't think it was one, but if it was, sorry for him. But Gay-Lussac's law deals with both pressure and temperature, and it looks very much like Charles's law. It's going to be P1 over T1 equals P2 over T2. We do need to pay attention that pressure is in a kilopascal and temperature should be in Kelvin. When I look at my problem, if a gas of a closed container is pressurized from 1,719.9 kilopascals, which I can't seem to highlight. Hello. There it goes. It's pressurized from, that's my P1, and it's pressurized to 1,623.2 kilopascals. That's my P2. If its original temperature was 55.0 Celsius, that's going to be my T1, which I just realized I didn't put my one. What would be the final temperature of the gas be? So we are looking for our T2. So the first thing I need to change is my temperature. So my T1, which is at 55.0, I need to change that into Kelvin. So add 273. I'm going to get 328 Kelvin. So just like Charles's law, we are going to do cross multiplication. We can go ahead and do that first if we want to. That means we would get P1 and T2 equals T1 and P2. Since we're looking for T2, that will work out very nicely. So I can go ahead and put my pressure 1 as 1719.9 kilopascals. T2. We're out of room anyway. And my T1, which was 328 Kelvin, and my T2, 1623.2 kilopascals. Okay, so I'm going to multiply. Let me go ahead and put my left side down, see if I can get it down a little bit neater. Alright, so after I multiplied everything on my right side, 53249.6. Technically, that is 8 Kelvin times a kilopascal. Then I'm going to divide both sides by my 1,719.9 kilopascals. Oops. 0.9 kilopascals. That cancels out my kilopascals, leaves me with a Kelvin, and that cancels those out over here. So my final answer is going to be, I got 309.5. I need 3 sig figs, so I'm going to have 310, and I'm going to put a decimal to represent my 3 sig figs. Again, if I look back up at my equation, I have 4 sig figs, I have 3 sig figs, and I have, no, sorry, 5 sig figs, 3 sig figs, and 5 sig figs. So I need 3 sig figs, so I have 310 with a decimal Kelvin as my final for this problem.